Okay, in this tutorial we're looking at adjusting the domain so that the composite function exists and then finding the domain and range of the composite functions. Okay, so for h of x it equals the sine of x, but we have a restricted domain. So going from 0 to 2 pi, I'll get one complete cycle of my sine curve, but I have an open circle at the other end. So the domain is 0 to 2 pi as a restricted domain, and my range will be -1 to 1. And my g of x is a square root graph that looks like this. So the domain of g will be 0 to infinity, and the range of g will be 0 to infinity. Okay, so now we're looking at O of x, g of h of x. And for that to exist, the range of h has to be a subset of the domain of the outside, which is g. So the range of h, and this one is h, -1 to 1, has to be a subset of 0 to infinity. And it isn't. Therefore, g of h of x does not exist. But we are now asked to adjust the domain of h so that it does exist. Okay, so we're going to go through h of x first. That's my inside. And once it comes out of h of x, it then goes through g of x. And we know from what we've written up here that what goes into h is 0 to 2 pi. And what comes out is -1 to 1. And what goes into g is 0 to infinity. And what comes out of g is 0 to infinity. But we have problems here. And our problems are that only positive numbers can go in, so therefore that -1 has to change to a 0 inclusive. And if that's the case, then the range of h has to be 0 to 1 only, which means its domain has to stop at pi, like an equal pi. So now my domain of h is 0 to pi, and that will produce a range of 0 to 1. Working the other way, 0 to infinity can go into g, but the only numbers coming out of h will be 0 to 1, so that has to change to a 1. And then the range will be, range of this will have to stop at 1, which means x value would be 1. So that's going to stop at 1. So the domain of GOH is the domain of h, which is 0 to pi. The range of GOH is going to be 0 to 1, because that 0 to 1 comes out, and that fully matches 0 to 1 going in, therefore 0 to 1 coming out. And the rule, I'm putting h inside of g. I'm putting h inside of g. So I'm going to have the square root of the sine of x. The second example looks at f of x and g of x. And f of x is a square root function. It's moved over here to 1 and shoots like this. And this one has been moved over 3 units, shoots the other way, but has been moved up 1. It will then look like that, where that is 1, 3, and 1. Okay, so the domain of f is 1 to infinity. The range of f is 0 to infinity. The domain of g is minus infinity to 3. And the range of g is 1 to infinity. I'm looking for gof, g of f of x. And for that to exist, the range of f has to be a subset of the domain of the outside, which is g. So the range of f, 0 to infinity, has to fit in through minus infinity to 3. And we have a problem. That doesn't happen. So let's draw out our situation. It's going through f first. So here is my f of x. It will come out of f of x and it will then go through g of x. So my x value goes in here. What comes out then becomes the input for g, and this is what comes out as my end result. So from what I've got above, for my f's, I've got 1 to infinity, 0 to infinity. I've got minus infinity to 3. Whoops, that's the bracket. And that should be 1 to infinity. Okay, pick a different colour. This coming out and this going in. Okay, so if it is zeros coming out, then that has to be 0. The only things that can go in through here are 0 to 3. We need to change that to a 3. I can now have a square bracket on the 3, and I will have a square bracket on the 0. So, coming back to my f, if my range of f is 0 to 3, if my range of f is 0 to 3, then my range of f is 0 to 3. These are the x values that I want to give me a height of 3. So I have 3 equals the square root of x minus 1, 9 equals x minus 1, x equals 10. That's going to be 10, which means that my x values can go from 1 to 10 inclusive. And that will throw out a 0 to 3, which means a 0 to 3 is the input into my g's. If I'm going from 0 to 3, these are the only x values I'm going to put in. Therefore, I'm going to go from 1 to whatever this will be, and that will be, when x equals 0, root 3 plus 1. So it's going to go from 1 to 1 plus root 3. So my domain of GOF will equal the domain of f, which is 1 to 10. The range of GOF will be from 1 to 1 plus root 3, and the rule will be f sitting inside of g. This sits inside of there, so I'm going to have g of f of x is going to be the square root of 3 minus square root of x minus 1 plus 1. And that's what the rule is, and that's what the domain is, and that's what the range is.